Hello everybody. Today we're going to continue taking a look at finding the area of rectangles. Yesterday we took a look at some arrays that had the grids filled in or the tiles filled in partially, and we could use those to help us find the area of the rectangle. Or if we had a whole grid like a tiled floor with some of it covered by a rug, we could find the area of the whole floor, even though some of it was covered. Today we're kind of doing a little bit of the opposite. We're putting some rectangles on top of a grid, and we're going to find the area of these colored rectangles, but we can use the grid it's put on behind it to help us. So let's take a look at this first rectangle up in the top left here. As you can see, we've got this green rectangle and it's on a grid. So you might be going, well, there's no side lengths labeled, there's no squares inside, how am I supposed to find the area? Well, remember guys, area is found by multiplying the length of one side, or the number of rows, times the number in each row, or the number of columns. And we can also talk about this as it's really most commonly known as length times width. How long it is times how wide it is. Okay, so if we take a look at this first one, we can determine that the left side and the right side are 1, 2, 3 units long. Let's say these are all inches, so we'll label this as 3 inches. Now we can check the top or the bottom side. It doesn't matter which one. 1, 2, 3, 4 inches. So we can label our side lengths. And now to find the area, we can simply multiply, right? We can use our multiplication to find the area. So we can take 3 times 4 and find our area. Now at this point, I suspect you may already know 3 times 4. If not, go ahead and count by 3s or count by 4s to help you solve. So 3, 6, 9, 12, or 4, 8, 12. What we want to get away from is having to do all of this. Okay, we don't want to have to draw those grids in anymore. So we're going to move away from that and use just our equations. So 12 what? Sparkly unicorns? Pickles? Square inches. Remember those units. We want to make sure we label everything. So label your side lengths and label your area. Let's take a look at this longer rectangle on the right. Let's see. We'll find the side length of the right here. 1, 2, 3, 4, 5 inches. So I'm going to label my side length. And 2 inches. Label this side length. How would I go about finding the area? I'm going to do 5 times 2. And you guys probably know that one right off the bat. 10 pickles. Square inches, right? You guys will get sick of me saying pickles until you guys get in the habit of those units. Let's take a look at something that's a little bit larger. Let's use some, well, we've got a lot of green. Let's use purple. Let's take a look at our left side. We've got 1, 2, 3, 4, 5. And our top, 1, 2, 3, 4, 5, 6, 7. And I didn't label, so let's make sure we label 7 inches and 5 inches. Now you might be saying, oh, I don't know my 7 times 5 fact. But if we know that we're going to end up doing 5 times 7, you've got strategies to solve that. You could break up your 7 into parts if you wanted to, or you could simply skip count by 5s 7 times. That's what I'd do. 5, 10, 15, 20, 25, 30, 35. So I know my answer of my area is going to be 35 square inches. One last one so you can take a look at what happens when we get really big. This is why we want to move away from having to draw the lines. When we see something large like this, we do not want to have to take the time to draw all these lines. And it's a lot easier because I'm working with a grid paper in the background. But when you're working just on paper, it's hard to get those lines straight and neat and organized. So we want to move away from that. Let's take a look at our side length on the left. 1, 2, 3, 4, 5, 6, 7 inches on the left. And 1, 2, 3, 4, 5, 6, 7 inches on the top. So we have a 7 by 7, and that makes a special type of rectangle. It's a square, you're right. So we're going to do 7 times 7. Now this is a fact we haven't practiced a lot, right? You guys haven't done a lot of skip counting by 7s yet. You haven't done flashcards by 7s, but you do know how to do the distributive property. I would take one of these 7s and break it up into a 2 and a 5. I know my 2 facts well, and I know my 5 facts well. That's going to make this way easier. Now all I have to solve is 7 times 2 plus 7 times 5, both of which I can do pretty easily. And in fact, I believe I just did 7 times 5, didn't I? I already know that's 35, so I can put 35 here. And I know 2 times 7, or 7 times 2, is just 7 doubled, so I know that's 14. So I can add 14 and 35, and I know 10 and 30 is 40, and 4 and 5 is 9, so I have 49 square inches. And it's nice to go back up and make sure you put it in the actual original equation. So when you're doing your activity today, when you're doing your assignment, do the work out, but then make sure you write the multiplication problem with the area as one piece. So like, I want to see this, but I also want to see your work. How did you figure it out? If on something like these you skip counted, it would be really nice to see your skip counts. 5, 10, 15, 20, 25, 30, 35, though it's not necessary, okay? If you skip counted, it's not necessary to write your skip counts unless that helps you keep track. But if you are going to do something like 7 times 7, 8 times 9, 6 times 8, those I should see some distributive property or skip counting happening, and I would like to see the work for that. So go ahead, find the area of these rectangles using the grid behind it to label your side lengths, and then find the area. Have fun and let me know if you need any help.